Question 5. You've got a alternating display. It says describe how the potential of the live terminal varies with respect to the neutral. So what we've got is trace A. If you look at it, it's fluctuating, alternating, and that's exactly what we say. The potential difference alternates, that's one mark, between positive and negative. So that region is positive, that region is negative. This is a very personally, I don't think it should be part of your syllabus. It isn't. It was an old question. But those of you who are interested, it's the potential difference. The trace B is a potential difference of the neutral wire with respect to the earth wire. I think there's little information for you to even figure this out within the question. Right, this is what we've done in class. So what is the time period it means, of the electricity supply? So the time period is one complete cycle. So that's one between this point and this point. So that's 1, 2, 3, 4, 5 squares. Each square represents 0.005 seconds. So that's 5 squares times by 0.05, 0.005, that's 0.025 seconds. And frequency is 1 over the time period, and that gives us 40 hertz. Question 6, you've got a resistance of 50 kilohertz or 50,000 hertz, voltage of 230 volts. You've got calculate the current. So if you've been given the resistance and voltage, you just rearrange this. There's your resistance, there's your voltage. Current equals the voltage over resistance. The voltage was 230 as given here, and the resistance is 50,000, so the current is 4.6 amps. So this is a difficult question, but nevertheless, it's a good question. So you've got rubber as a good insulator, and explain why it's a good idea for electricians to wear rubber-soled shoes. Now, the person's overall resistance will increase if they are wearing any insulating material. So wearing rubber shoes increases the overall resistance of the person because rubber is a good insulator. So it's high resistance. So the overall resistance of the person increases. This means less current can flow through the person, which means that less shock, the person can experience less shock, so it's safer. Do not think that the person does not experience a shock. There is still a possibility because the person still has some resistance. Part B, again, this was a very difficult question. A lot of students didn't figure what was going on here, but what we need to do is first, we need to know what the frequency for UK mains electricity is 50 hertz, same as Abu Dhabi. From a safety point of view, is the frequency of the UK mains electricity supply suitable? So we look at where's 50 is over here. If you don't go there and across, that is just under 10 milliamps. So what does that mean? It means it's the current at which a person was unable to let go. So that is the current at which the person was unable to let go. Now, if the mains electricity supply was 20 hertz, that means that we can let go at higher currents. 90 hertz, we can let go at higher currents. However, at 50 hertz, That's the least current compared to all the others where we can let go. So that's actually more dangerous. So from a safety point of view, you've got, is it suitable? No, because it has the lowest current at which the person could let go compared to the other frequencies. You could have said yes and said that these currents are not much different to this current. So that current and this current are not much different because it's milliamps tiny. Question 7. Here is where P4 and P5 overlap. You've got 20 lamps connected in series. So it's a series circuit. 230 volts is supplied. Now 230 volts is shared amongst the 20 lamps. And a current through each lamp is 0.25. So the current here is 0.25. So what is the current drawn from the mains electricity supply? Remember, a series circuit, the current is the same everywhere. So the current is 0.25 everywhere. Okay. Calculate the charge passing through one of the lamps in 5 minutes. So we've got time, we've got current. Okay. So we want to work out charge. So we know formula, charge equals current times time. So the current is 0.25 amps. The time is in minutes. We've got to get into seconds. So it's 5 times 60. So we get a charge of 75 coulombs. That carries a mark. That carries another mark. That carries a mark. And that carries a mark. So overall, that's 1, 2, 3. And finally, you've got, if you read that question out again, you've essentially got one of these lights that stops working. And the person, rather than replace it with another light, they put a piece of aluminium from one end to the other end. So making it act as a wire. Now the electricity will flow and all of the other lights will light up. So just now think, each bulb has a resistance. By not having that bulb there, that means that the overall resistance in the circuit has dropped. So the overall resistance decreases because the fault has not been fixed. If the overall resistance decreases, that means more current goes through the wires, i.e. more current goes through every single bulb that's remaining. 230 volts has been supplied. It was supplied to 20 lamps, but now it's supplied to 19. So that means each lamp will receive a larger proportion of the voltage. So now you've got two factors. You've got a larger current through the remaining bulbs and a larger voltage through the remaining bulbs. That means that the wiring will get hot, the bulbs will get hot as well. And that may cause a fire in the wiring, okay, after they start to overheat.